This was created in a program called Grasshopper, and I post videos like these every week so you can learn the process and create parametric designs using the techniques that you learned here. So thank you very much for joining. If you want to get a hold of the script that I created for this video, check out my website, competidavid.com. There you can download the script for free the first week, and I also have other resources that can help you get started with Grasshopper right away. So like I said, thank you very much for being here, and let's jump right into the tutorial. So to start, what I'm doing is I placed a person here just for scale, and now we're going to get started by creating a rectangle. So we'll go rectangle. We'll be using this rectangle component and plugging in the inputs. So this is going to be the different room sizes. I'm just going to create 2 sliders and use a 20 by 20. Now what happens is this is only creating one rectangle, but let's say we want to create more than one rectangle or more than one room. Then we copy this, and holding down Shift, we can add an additional X and Y. And if we do this a few times, you will see that it will actually create the same amount of rectangles. So now that I've plugged these in, we can change the size, and we see that they're overlapping, which is okay because the technique that we'll use is open nest, and open nest will let us take these overlapping regions and align them in a way that they're packed correctly. So now that we have all of these different room sizes that we can change, there's also another ability to do this. We can use a gene pool, but with gene pool, we would have these values and then another set of values for Y. And I actually like having the X and Y value next to each other, so you can change, let's say this being one, this being another one, and I'm grouping them so you can see them here. So each one of these is a separate box that's going to determine a different space. So with this, let's see if we can organize it a little bit. Okay, so now that we have this, we're going to pack these objects down here and align them. So the way to do this is make sure that you have OpenNest downloaded. You're going to need that plugin. So that's going to be here under parameters, OpenNest. Now with OpenNest here, we can use 2 different components to first align them. One is going to be pack objects, and the other one is going to be to project. And these are different components than the ones that you find by default in Rhino. And this is why it is powerful to use tools like OpenNest. Now let's take these rectangles, plug them into the polyline. But what we need to do is, this is a rectangle, so we need to route it through a curve component. Now we can use this as our polyline input. And now this polyline can be both for the plane and both for the curve. As you can see, what it does is it organizes them by the way that they were organized originally. So this is the first one, and so on. Now that we have these packed here, we can give it a tolerance or an X and Y spacing. As you can see here, we have a gap. So if we want to reduce the gap, we'll go to 0. And now here under X and Y, we'll go to 0. And as you can see, now they're aligned. And with this, we are able still to change some of these sizes and have them update automatically. Now this is already very useful in the sense that you can align spaces like this and have them basically be reorganized and packed in this fashion. But this sometimes does not give us the ability to randomize the spaces. It will just pack them according to their original organization. So with that being said, now we're going to take these packed objects and we're going to use the OpenNest component, which will take care of the rest of the organizing. So what we'll do is start with our geometry into the geometry input. The sheets, well, we need to create a sheet in which the spaces are inside. So this is why I create a rectangle. So we'll start by creating a rectangle. And this rectangle is going to have a specific size that is larger than all of these spaces together. And you'll see why. Because that is where the region in which these spaces are going to be organized. These are going to be packed in here, and we can change the region in which they are packed. In the same way that you would do with a sheet for printing or for CNC cutting, we would take this rectangle. We'll go here into the curve component, and we'll be using this as the sheet. As you can see, we already have this packed on here. And if we decrease the size, let's say of the space, they will get repacked in a different way. So this almost works as a limit for length and for it to be reorganized. So that's one of the things that the sheet does. Now, the other thing we got to do is hide the original line work because we don't have to look at that. That is the work before. This is the work before. And now there are another set of inputs that we want to change. I'll go to 0 for tolerance or for spacing. Rotations is how many times can you rotate this to change the solution. So if we rotate it 4 times, or 90, 90, and 90, then we can use that as a rotation. And now seed is going to be if you want to have more randomized options. So for that, I'll go to 3, and I'll plug that into seed. Now with this, we can move the seed around and see how these are packed. But as you can see, they're being organized out here because that's the most efficient way to organize a region. Now what we need to do is decrease the size this way and decrease the size this way. And we can still play around with some of these spaces. Now we have the ability to rotate and change it around. And we are not necessarily done here. We could always add another set of rectangles and then have this one be larger. And if you need more sheets, it will open up a new sheet. So for that not to happen, we would change this. And now that we have, let's say, this region in which we want to keep our design, then we can change our seed to have different results. So this is the way that I am going to now organize the spaces and show you how to create an outside wall, inside wall, and then openings both for the interior and for the exterior. So at this point, there are a few things that we can do. Number one is notice that the geometry and the sheets are in the same component. So I will basically extract just the geometry with this component. And then I'll disable the preview on this. We have the spaces and the outer region. We don't necessarily have to look at this. So now that we have this layout, there are 2 things to do. First is going to be region union. What that will do is basically Boolean union and using regions to bring this together into one polyline. What we'll do is we'll offset this to the outside. And we'll give it a distance of 1.5, and we can always change it. Okay, so now between these two, we're going to create a surface. So we'll go to boundary surfaces. And as you can see, they're overlapping, so we'll flatten the input. And that will bring it into a list that is just one list, and it will create that surface in between, which we can now extrude The direction is going to be up in the Z direction. And the factor is going to be 12.5 for 12.5 feet. Now these are all going to be the same height. I thought about creating a variation in height, but I don't want to do that in this exercise. I want to show you how to create these random layouts with spaces. So now that we've basically created the outside wall, now we want to create the inside walls. For this, there's a bit of a trick. We want to extract all of these line segments individually, and right now they are like the entire thing here. So to fix this, I found one technique, which is going to be to create the surfaces first. And now that they're surfaces, I can do join vrep, flatten the input, and make sure that here under VREPs it says one open VREP, which is good. But we still have these creases here, which we're going to extract using VREP edges. As you can see now, we have all of our line work, but they're separate. So this is a separate line than this, than this, than this. So what we need to do now is both the naked and interior curves, we're going to offset them both to both sides. So this is positive, we'll do positive 1.5, or actually no, it'll be 0.65. Okay, 0.65 to the outside, and then 0.65 to the inside. And so far, we're only doing that to the naked or the outside curves. So now we want to do that also to the interior curves. So I'll hold down Shift and add those. So basically, it's taking all of those lines, offsetting them to the left and to the right, or to the both different directions. And now we can loft together the first set and the second set. What that'll do is basically takes this line, offsets it one way, offsets it the other way, and joins them together. And now we have these overlapping surfaces that we want to use region union to bring together. So now with region union, we can basically plug in that loft into the input, flatten the input, and get the clean line that's going to be on the inside of those walls. So now here, we'll disable the preview on this and disable the preview on the original line work. And now with this, we can go boundary surfaces to create a surface there and extrude to the same height. So I'll take this, copy it, and this one will be what we'll extrude. So now we have overlapping walls here that we can subtract using difference. Solid difference. And now I can use the inside walls as A because that's what I want to keep. And I want to subtract I want to delete what is overlapping. So now here I can go to geometry node and use this as my component and use this as my interior walls, and I can hide and disable the preview on everything else here. So now we have outside wall, inside wall, and now we can focus on creating the openings for these. Let me show you kind of the power of this, because some of the cool things that we can do is the fact that we can change these and get brand new results with super clean outside wall, clean inside wall, and we can change the offset, because since we're offsetting both to either side, then we can take this and do divide by 2, because right now it's going to 1 point something. So if we divide it by 2, that'll make it the 0.6 or 6 inches. Or actually 0.5 is going to be 6 inches because it's half a foot. So with that, you have walls that can cover the concrete wall or whatever this outside wall is, and you have these really clean interior walls here. We can also, just before we move on, change the sizes. So if this room is too large, it can change. And of course, there are going to be some iterations that may have, let's say, maybe something like this, like a courtyard in between. If you don't want that, then you would go here to seed. You just get a different one. Okay, so now let's move on to the doors and the windows. So for this part, we need to go back to our curves here, because if we take a look, we have interior curves, we have exterior curves, and if we just take the interior line work and we bring it here, so I'll go to a curve, bring this interior line to here. Now we can take these curves and get the midpoint. Now that we have the midpoint, that creates the spot for where the doors would go on the interior, because these are all the interior lines. Therefore, at this point, we can create a circle, which means that it's from the center. So the radius would be 3.0 divided by 2. And this will be the door opening. It could be 6 feet, it could be 3 feet. Because it's from the center, 3, or half of 3 and half of 3, which makes a whole 3. And now we'll go here to circle, we'll go to extrude. In which direction? We'll up. So in the Z direction. And this is where we give it a height. So 8.00 for 8-foot door. And if that looks like the correct location, we can also randomize the sizes, but typically for interior doors, they're going to be like a standard size, whether they're double doors or single doors. Now we'll go to this extrusion, bring in a box around it. And now subtract the box from the interior walls. So this is where I'll go to difference, solid difference, and B is going to be the doors, and A is going to be the walls. So I'll use this one. The reason for that is because I can bring this here and just plug that there as the output. And we can disable the preview here on these doors. Now we're on to the exterior. But before that, I want to show that we still can change these. And the doors will be exactly in the center. The only issue I see is if at some point the room overlapping with the room next to it is smaller than the width of the door, that's where we can find a conflict. And I'm pretty sure that if I just run through some of these, there will be one of those. But for the most part, like in this one, there's a weird one right here. You wouldn't want that. So in that case, you could either increase the size of that or just change this a little bit. Like this little bit would be a bit of an issue here, but okay. Now let's create the outside doors. I want to change this back here. This little bit is the one that's being weird. So that's why. We'll use this one for now. Okay, next is going to be doing the same thing but to the outside lines. So what I'll do is I'll actually take all of this, slide it down, tap Alt, create a copy, because we need to do the same thing for the outside ones. But notice that it creates it for all of them. And we don't necessarily want doors in every single one of those. We want them to be either random or pick them yourself, right? So with this box, rather than using all of these midpoints where they are located, why don't we just use one of those points, or have the ability to pick those points using list item. Now that we pick one of these points, now if I plug in those midpoints into the list, the index of 0 is going to be here. So that is the only location in which the door would go, and this would be our input. Now for the index, we can change it depending on which number or which location, which door, where you want the door located. How? We'll go to point list. Point list will tell you the way that the points are organized. So we have a bunch of midpoints. Let's see how they're organized by plugging in the points here. And the size is going to be, let's say 1.5, if that's not too big. Okay, so if you want a door on this side and on this side, we would put it on 11 and 12. And so therefore, either we would bring in a panel where when we right click, it's going to be a multi-line data. We can now plug this into the index, and we can say, I want 11 and 12. Again, 11 and 12 to be the location of the doors. Now, disable the preview on this, and you'll see that the doors are only located at those two locations. And now let's place another one here at 1 and at 5. You can either do them in organization, or you can do them like this, 1 and then 5. And that's how they would be organized. So 11 is 1 now, 12 is, or 11 is 0, 12 is 1, 1 is 2, and 5 is 3. The door size is going to be double, so we can do a pair door here. Now we can do a solid difference between the outside. We actually have to do Boolean difference on all of them. So we need to do Boolean difference on the interior walls because it creates this little bit. Oh, actually, it has to be on this one because this is the one that's already been subtracted from. And now we'll do the outside one, which is this one. So now everything here is old. We can disable the preview on the boxes and see that I missed the mark on this one. It was supposed to be, I'm going to go back where it was. So this is the outside wall. That's the one that I missed. The outside wall first, subtract from it. And then the inside wall, subtract from it. So I messed that up a little bit there, probably confused you a little bit, but the idea is that when you have the outside and inside wall that already have the doors subtracted, then you have to subtract also the outside doors. So with that, and disabling the preview here we have this layout that has a perfect floor plan in terms of having the walls lining up with the outside walls, having them have material inside, a wall on the outside, doors, both outside and inside. And so that will conclude this exercise, because the idea for this was more than anything to create rooms that have, you know, whatever size they are, be packed and reorganized using OpenNest, and then developed using this script, where we basically create the offset for the outside wall, inside wall, and openings. So thank you very much for being here. I will clean this up and share it with you guys on my website, capettidavid.com. There you can find this script and other scripts. You'll have it free for the first week. And then if you join the membership, you can access a lot more resources. So thank you very much for being here. And if you have any questions, let me know. Otherwise, stay tuned for more. Thank you very much for watching, and I hope to see you on the next one.